Welcome back to the class, children. In the previous class, we were discussing about structure of atom, and in this chapter, we all already discussed a subatomic particle, that is electron. Today, we shall learn one more subatomic particle, that is protons. So, protons are the fundamental particles, or we can say they are the subatomic particles of an atom which carries positive charge and a unit mass, that is 1 U. So it is represented by the symbol P plus, and its charge is 1.6 into 10 to the power of minus 19 coulombs. Next we shall learn discovery of proton. Who discovered protons? It was Eugene Goldstein, a German scientist, who discovered protons. How he discovered? He did an experiment. How Thomson did. J.J. Thomson, you know that, who discovered electrons, that you have learnt in the last class, children. Goldstein also repeated the Thomson's experiment by modifying the discharge tube that you have learnt in the last class, and he used a perforated cathode here. Perforated cathode means which has holes. The cathode plate has the holes here, and it was placed somewhere in the center of the tube and not at the end. If you observe this picture, you can see that the cathode plate, which is placed in the center, near the center of the cathode, discharge tube, and it is perforated, means it has holes, and it is not placed at the end. And he used hydrogen gas inside the discharge tube, where hydrogen gas was enclosed in the discharge tube, and the experiment was performed in the same way as was done by J.J. Thomson. So this was the setup done by Goldstein. You know that J.J. Thomson also did the experiment for while discovering electrons. He just used a discharge tube which was fitted with electrodes on both the ends, but he used the cathode which is somewhere near the discharge tube, and it is perforated. That means it has holes in it. After that, to his surprise, when he uh, placed the cathode and he again did the experiment same as J.J. Thomson done, to his surprise, he discovered new types of uh, rays which were emitted from the tube. So they passed through he discovered a new type of rays here. What are those rays? And they passed through the perforation of the cathode. That means they passed through the perforation through the holes of the cathode, and which were emitted from the tube and moved away from the anode. As shown in this picture, you can see that the rays which is coming from the anode, the blue color rays, they are the anode rays. They are moving away from the anode, and even they pass through the perforation of the cathode. That means even they move from the holes of the cathode. So the rays were named as anode rays, because since they are coming from the anode, they named as anode rays. So as they were directed from the anode, so the rays were also called as positive rays, since they consist of positively charged particles. So the rays which are coming from the anode, they are called as anode rays, and they are also called as positive rays because they consist of positively charged particles. So initially people called anode rays as canal rays. Canal rays means as they seemed to be, they looked like a stream of water in a canal. That's why it can also be called as. So anode rays were called as canal rays because they looked like a stream of water in a canal. So Eugene Goldstein, done the same experiment which was done by J.J. Thomson, but little bit changes in his discharge tube, and he has taken a gas, that is hydrogen gas, but J.J. Thomson took air, normal air, and he started reducing the atmospheric pressure inside it. But Goldstein took hydrogen gas, which is enclosed in the discharge tube. So it was a perforated cathode, and it was placed somewhere in the center of the tube, as I told you, and not at the end. And he discovered new type of rays which are emitted from the cathode, named these named as anode rays, as I told you, and the rays were also called as positive rays, and because they are positively charged particles. And initially people called anode rays as canal rays because they seem to be like a stream of water in a canal. So these are the observations done by Goldstein. So if you observe this picture, children, during the time of 1886, Goldstein observed positive rays using a perforated cathode, as I told you. We all know that, so explanation for this origin of anode rays, how it was origin and how we did. We all know that the discharge tube contains hydrogen gas. So how it was considered as an anode rays? Because hydrogen gas, you know that hydrogen atomic mass is 1U. Under high voltage, these molecules, that is hydrogen H2 molecules, break into atoms of hydrogen. They broke into atoms of hydrogen, and high speed of electrons, which constitute the cathode rays, get an opportunity to collide with the hydrogen atoms. The electrons which are coming from the cathode, they collide. Collide means they just bombarded or hit with each other. They collide uh, with high speed or collide with the hydrogen atoms. As a result, electrons are knocked out of these atoms. So inside the atoms of hydrogen, the electrons which are present in the hydrogen atoms, they knocked out, they came out. As a result, electrons knocked out of these atoms, leaving behind only positive charged residue. See, when the electrons which are coming from the cathode, children, they got an opportunity to collide with the hydrogen atoms which are present in the anode, that is positive. When they collide, they knocked out the electrons which are present in the hydrogen atom, and finally when the electrons came out, only positive residue, that is hydrogen atom, left behind. So they constitute the anode rays. They are the anode rays and move through the perforation of cathode. That means holes of the cathode. This means that anode rays are or positive rays consists of positively charged residue that are left when the electrons are removed from the atoms. So this is said to be anode rays. The rays which are coming, they are nothing but hydrogen atoms which are free from electrons. They contains only positive residue. They are nothing but protons, and they are moving away from the perforated, or moving through the perforation of the cathode. So in the case of hydrogen gas, when enclosed in the discharge tube, these positive charged residue were called protons, and they are nothing but protons. Actually, the name protons, arise from the word protium. Protium is nothing but what? Which represent hydrogen atom. Hydrogen atom is also called as protium because hydrogen atoms are present in the hydrogen gas which is enclosed in the discharge tube. Since hydrogen gas inside it contains hydrogen atoms. So it is the positively charged residue left when an electron is knocked out, when it came out of the hydrogen atom or protium. So proton is represented by the symbol P, as I told you earlier. And when the experiment was performed with some other gases instead of hydrogen gas, he used other gases also. the positive residue were different and were actually aggregate or multiple of protons, because hydrogen contains one, each hydrogen atom contains only one proton, but in other gases the protons will be more. So multiple of protons were present. Thus we conclude that anode rays consist of positively charged residue particles known as protons, formed by the removal of one or more electrons from the gaseous atoms. So this is how Goldstein discovered the protons, children. Let us learn the characteristics of anode rays. What are the characteristics, important characteristics of anode rays? You know that anode rays are nothing but the protons, particles, and they always travel in the straight line. And anode rays consist of positively charged particles known as protons. The nature of the protons or nature of the anode rays depends upon the gas enclosed in the discharge tube. It should not be only hydrogen atoms, any hydrogen gas, it could be any other gas. So it depends on the gas which is enclosed in the discharge tube. So they are deflected, they can be deflected by using electric and magnetic fields in the direction opposite to the cathode rays. You know that even in the cathode rays could be deflected using electric and magnetic field. Here it is opposite to cathode rays. So these are the characteristics of anode rays, children. Let us learn the neutrons, how neutrons were discovered. So neutrons is another subatomic particle and of an atom. It is present inside the nucleus. That how a nucleus was discovered you will learn in the next class, and it carries no charge. There is no charge in it, and it was discovered by James Chadwick. So these neutral particles were actually discovered by James Chadwick in the year 1931 when he bombarded. How he discovered it? He bombarded means hit a thin foil of beryllium metal with fast moving alpha particle. When alpha particle hit on a foil of beryllium beryllium metal, uh, each particle was found to have mass equal to 1.67 into 10 to the power of minus 7 kg, which is nearly the same as that of proton. So neutron mass is 1.675 into 10 to the power of minus 7 kg, which is nearly equal to that of proton. So however, it do not have any charge. That is, it is neutral in nature. So neutron is neutral in nature. Therefore, it is known as neutron. The name is given as neutron because it is neutral, and it is denoted by the symbol n, small n. Thus, neutron may be defined as, how it is defined? It's a fundamental particle present in the nucleus of an atom which carries a mass of 1.675 into 10 to the power of minus 27 kg, and it is regarded as 1 unit mass, that is 1 U, and no charge, and mass is almost equal to the mass of proton. So these are the particles that are present in an atom, children. That is, electrons was discovered by J.J. Thomson. In last class you have learned. Protons were discovered by Goldstein, and neutrons were discovered by James Chadwick. In the next class, we are going to learn more about structure of atom. I hope you have understood the experiment done by Goldstein. And in the next class, we are going to learn about more about atom, children. Thank you.